Alright, section 10.2 deals with mean, median, mode, and box and whisker plots. Alright, so I'm just going to give you a problem that deals with average or mean. And you have seen problems that look like this. So let's figure out how to solve them. So suppose you have 6 tests in a semester. It's getting to the end of the semester and you need to have an average of an 80% on the test in order to pass the course. You receive a 64, 74, 66, 94, and 88. On the first 5 tests, what do you need on the final test? Now keep in mind, there's a few different ways of solving this problem. I'm just going to show you one. So when we find average, the way we do is we add everything up and we divide by how many there are. Alright, so let's do that. Let's take 64 plus 74 plus 66 plus 94 plus 88. Now I know we have 5 tests there, but we need that 6th one. We don't know what it is. We can simply say it's x. And now we divide by 6 because we know we have 6 tests. I want an 80%, so we can say equals 80. Now we have an algebraic equation. So we multiply by 6 on both sides to cancel out the 6's there. And if I add everything up on the left-hand side, I get 386 plus x. And 80 times 6 is 480. I subtract the 386 from both sides, and I am left with a 94%. So why does this method work? I want to show you. So let's talk about what is average exactly. Well, mean or average is simply the number expressing a typical value in a set of data. Oh, number expressing a typical value in a set of data. So in other words, it's what you typically get. It's not what you always get, but it's your just typical. Okay? So suppose that I have this set of data and I was trying to figure out, well, let's survey some students and see how many letters they have in their name. All right, so I surveyed 8 students and found out how many letters were in their name, and I made this nice little bar graph. So what I'm going to do is I'm actually going to copy that. Okay, so now that I have it copied, I can tell you what I'm doing here. So I'm going to ask my students after I graphed all this, and we're going to look at the first graph. And typical, yes.
You're all done.
Are you?
Can I see it?
Sorry. So the mean is our typical value, or in other words, the typical length of our name. And so we're just going to find the area of that box. And so we know that this is 5 and this is 8. So basically, we're taking 5 times 8, or we're taking 5 plus 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 5 to get our area. And we said that our area is 40. Or we can say that its area is equal to 5 times 8. And that's why when you add everything up, so when we added everything up, we got to 40. In other words, you add them all up, which is 40. We divide by 8, and that gives us our mean. Okay, so basically you're undoing this. And that's kind of in a nutshell what it is. It's basically area, and you're trying to find the height of that rectangle. So let's write down our definition. So the mean is equal to the sum of the data points divided by the number of data points. All right. Okay, so there was an area model to represent the mean. That was actually just what we did, so we don't have to fill that in. But what about a balance point? Okay, this is where basically you have a balance beam and you want to know where would it stay balanced at. So let's say that I have a 1, 2, 3, 4, 5, 6, 7, 8, and 9. So it's kind of like this. If I put some kids, and let's say I put one kid on the balance beam and instead of 2, let's say he weighs a certain amount. And we've got this other kid weighs a little bit more. Another kid that weighs, a couple kids that weigh this much. And we got somebody that weighs this much. Then we got somebody that's a little bit heavier and somebody that's a little bit heavier, they're here, and then we've got somebody that's a little bit heavier here. Remember when you're in a balance beam, where you're placed, how much you weigh, means that your balancing point is going to be at a different spot. It might not be in the middle of the board. It might be toward the end of the board. You might have a kid on one side that weighs 100 pounds and, 2 other kids on the other side that weigh 50 pounds. Or one kid weighing 50 pounds. And so then that kid's going to have to shift way to the end, and the one kid that's going to be on the other end is going to have to get closer and closer to that middle. Okay, so a mean can also be a balance point. All right. So let's look at an example. The mean weight of 5 boys is 46 kilograms. When another boy joins the group, the mean weight of the 6 boys becomes 48 kilograms. How much does the 6th boy weigh? Okay, so let's break this apart into 5 and 6. So let's look at with 5 boys. And then we'll look at with 6 boys. Okay. So remember, the mean is equal to basically our total weight, or in other words, when we add everything up, divided by how many boys there are. In this case, there's 5 boys. All right. So when we only had 5 boys, we said the mean was 46. We don't know that that total weight, so we're just going to put the word total there. And we know that there are 5. So basically, if I take 46 times 5, which is 230, that is equal to the total weight of 5 boys. All right, now let's look at when there's 6 boys. We're going to use that same equation. But this time they said when the 6th boy is added, the average becomes 48. We don't know our total, but what we do know is now there's 6 boys. So if I take 48 times 6, I get 288 is equal to my total of 6 boys. So in other words, if I subtract those two things, that'll give me the difference in weight, which would be that 6th boy. So the 6th boy is equal to 288 minus 230, which is 58 kilograms. And so that's a little bit different type of problem, but we're using mean. Okay, so that's the mean. Find the total, divide by how many there are, and that'll give you that typical value that each person would weigh or be. Okay, we're going to shift gears a little bit. We got the median. The median is if we have a set of data points, it's always the middle number. We want to keep in mind, you always want the data to be in order. So always order your data. And so what I mean by that is if I had these data points right here, you can see that they are not in numerical order. So put them in order. We'll have 1, 1, 2, 3, 4, 5, 6, and 8. And basically you're looking for that middle number. So if we go from one end to the other, 1, 2, 3, 4, 5, 6, 7, 8. So I'm working my way in to the middle, and I can see that these two things are in the middle. So to find that exact middle, when you have an even number, you just add them up and you divide by 2. And so then the median would be 7/2, which is equal to 3.5 in this case. Now, if we had an odd number of data points, so let's say we have an odd number. Let's say we have 1, 2, 3, 4, 5, 6, and 7. And when we go from see our exact middle, we can see that the 4 is our exact middle, so that is the median. You can have no mode. So let's say no numbers repeat. Then you have none. So that can happen as well. Okay. All right. Find the mode of the following data. I just gave you an example, so we're gonna skip that one. All right, we're going to talk about box whisker plots next, but that will be in the next video. So watch the next video to talk about box whisker plots. Thank you.